Okay, so this is chapter 2, the very first section. This is stuff that we did on Friday, doing vertical line tests and the relation representations. One-to-one functions and onto functions we will discuss in detail what those definitions are. You saw discrete relations as you were graphing number 2 to decide if it was a function with the vertical line test. And when you were representing relations as the graphs, and you had the list of points or group of points in the graph, those are a discrete relation, a group of points on a graph. That's discrete. Continuous relation would be all those other graphs that you had as you were checking to see if the vertical line test showed you that the lines or the parabolas were functions. So those are a smooth curve, a smooth line that is continuously touching point to point. That's a continuous relation. And we'll go into that and see some more graphs. Then, of course, the vertical line test. A relation is a special relation. It's a function if it has any vertical line that passes through just once. And then we will discuss what the independent and dependent variable are, and I'll show you what function notation is. Okay, so you have This Cool Athletics introduced a new power sneaker in one of their stores. The table shows sales for the first 6 weeks. So does the data for the sales represent a function? Here is the data in the table form. And you take data, place x's in domain. You have y's in range. You can also take the map and represent it as the list of ordered pairs. You can take the table or the list of ordered pairs and graph those points. We can determine that, yes, this is a function. First, all the x's are different. That's why, yes, this is a function, because every x value is different. Yes, this is a function because this passes the vertical line test. If you look at this graph, any vertical line drawn through this relation passes through the relation only once. So at this point, here, 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 and here, any vertical line would pass through only one point. So it passes the vertical line test. This is also a function and is proven because you can see here as well in the list of ordered pairs that every x value is different. 1, 2, 3, 4, 5, 6, all different x values. And yes, this is a function because every x pairs with one y. No x has a second pair. Given a function, evaluate the function at each given value. Here is function notation. So function notation would look like a g, and what we say is g of x. We could also have an f of x. I'm not allowed to make fun of my handwriting when I'm not at a board. We can have an h of x. So we say of h of x, f of x, g of x. Those are functions. So given the function, evaluate the function at a given value. So we have this g of x function. We will evaluate g at 2.8, then g of 4a. This uses the substitution property. So for each x, substitute in the given value. This is just our function notation telling you we have g of 2.8, so that means substitute in 2.8 in for x. Substitute in 2.8 for the x. So you have 5 times 2.8 squared. 5 times 2.8 plus 3.5. And evaluating that out, 3.92 minus 14 plus 3.5, you get negative 6.58. In the case of g of 4a, we are substituting in 4a in for x, substituting in 4a for x. So 0.5 times 4a squared, 5 times 4a. And you do have to square before you multiply. What would that be? Order of operations. So that would be 16a squared times 0.5, 8a squared, this is 20a, and 3.5. No like terms, and you are finished evaluating.